Good morning. This is the notes for 3-3 in honors geometry. So 3-3, 3-3 notes. And the first item in these notes is this concept of CPCTC, which stands for corresponding. The C is corresponding parts of corresponding is the C, okay? P is parts. C is congruent. CPCT is triangles. And the last C is R. Keep hitting that mouse. Congruent. So what CPCTC does is this is used to prove that parts of congruent triangles are congruent. So after side, 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 angle, side, angle, side, angle, side, or angle, angle, side. So after you prove the triangle is congruent, you might need to use CPCTC to finish the proof. The second part of 3-3 is all radii are congruent. So radii are those segments that are from the center to the outside of the circle. That's what a radii is. So one is radius, more than one is radii. So plural equals radii. So every radii of a circle are congruent. So if I drew this radii and that radii, these two would be equal. If I drew another radii, all three of those would be equal. If I drew another radii, all four of those would be equal. If I drew another radii, okay, all five of those would be equal, and so on. There are an infinite number of radii in a circle. Okay? So let's look at a sample proof. The sample proof, okay, would look something like this. I'm going to draw a circle, and in that circle I'm going to draw a bow tie. And I'm going to put a P right in the middle, and I'm going to put a C here, a point D here, a point B here, and a point A here. And in this proof, we are given that, I think I'm going to do darker. We are given that the circle with the center of P, okay? And we want to prove that AB is congruent to CD. So we want to prove that this segment is congruent to this segment. And sometimes I like to put a question mark there. Now, you can see that we have two triangles. And you need to see that this angle and this angle are vertical angles. Now that's from the previous section. And in this section, before we start going into the proof, you need to see that this is a radius. This segment is a radius. This segment is a radius. And this segment is a radius. And all radii are congruent. That is a fact. So, what we're going to do is we're going to get the two triangles congruent by side angle side, side, angle, side. That's what we're going to do. And then we're going to use CPCTC to get this segment congruent to this segment, because those two segments are corresponding parts of congruent triangles, and therefore they are congruent. That's CPCTC. We will set up a two-column proof. We will write our statements over here and our reasons over here. And we will write that we have a circle at the center P. And that is given. Now, the second thing we will write is that PD is congruent to PB. Right, so PD is congruent to PB. And that is because all radii congruent. Whoops, that should be a 2 here. This third step is that PC is congruent to PA. And I'm going to write same as 2, because in step 2 we say all radii are congruent. Okay, so the fourth step is that angle APB is congruent to angle DPC. And that is vertical angles are, the reason is that vertical angles congruent. Now, step 5 is triangle APB is congruent to triangle DPC. And you can use the same angles up here. APB congruent to triangle DPC by side angle side. And that is 2, 4, 3. 2 is the first side, 4 is the angle, 3 is the third side. Now, we've got the triangles congruent, but we had to prove that AB is congruent to CD. So we're going to use the fact that the triangles are congruent in CPCTC. So the last step in the proof is AB congruent to CD, and that is because of CPCTC. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. CPCTC. That's why in this proof, AB is congruent to CD, because corresponding parts of congruent triangles are congruent. Okay? So I hope everybody writes these notes down. You can stop the video and go from there. Okay? Have a good weekend.